Everyone, in this video we are going to create MCP server and MCP client using springai. As we know by now that the communication between an MCP client and an MCP server happens on transport layer. There are two ways to do it. First is STDIO, which is on the right. Here, client invokes server as part of the same process. Second approach is server sent events. In this, client makes a remote call to the MCP server. Standard input-output transport enables communication through standard input and output streams. This is particularly useful for local integrations and command line tools. This makes more sense when you are building MCP for a local integration. Server sent events transport enables server to client streaming with HTTP post requests for server to client communication. This approach is the recommended approach for production. Let's build ourselves our own MCP server and MCP client. In this example, we will be using springai and using standard IO transport method. Also, if you like this video till now, be sure to subscribe to the channel. Let's create a Spring Boot project. We will be creating springai MCP server in standard IO mode. We'll choose Maven in Java 21. It works perfectly fine with Java 17 also. Take a note on the Spring Boot version and we'll choose MCP server as a dependency. That's it. Let's take a quick look at the dependencies that we have in the project. Spring version is 1.0.0 and we have springai starter MCP server dependency. Let's quickly configure this project. Let's move to application properties now. Here, the main thing is we have to disable the server's console logs because it interferes with the client's invocation of server. So we will do banner mode off and we will have to disable the logging made by the server. These two lines are very important if you are running your MCP server in standard IO mode. Now we have to turn on MCP server in standard IO mode. And here we will just name our server and provide the version name of the server. We will call this as weather server, and the tool that we are going to be creating in this will take the lat and long values and give out the weather for that particular location. Let's create a service for us. Inside the service, we will be creating a tool, and that tool's responsibility is to provide the weather. So let's notate this class with @service annotation. Now one thing to note here is in this class, I will not be making an API call to get the real service. It will be just a dummy service class for me that will give you the dummy weather for a given latitude and longitude. But if you want, you can make real API calls, database calls. That is not the purpose of this video. What I want to demonstrate by this is this method or tool getting invoked by the large language model to get some additional context. I'm naming this method as getWeather by location, and this parameter is latitude and longitude. So if the large language model feels that for a given latitude and longitude it needs the weather, it is going to invoke this tool. Inside the body of the method, I'm just writing some dummy conditions. If lat is 10 and long is 10, then provide some dummy weather. But as I said, you are free to make any database calls or network calls to get the real weather for your location. For this particular lat and long values, I'm saying the weather forecast is rainy. Let me quickly add one more condition similar to this. Here, let me make the lat as 20 and long as 20. And I'll say for this combination, the weather is stormy. And for the default case, I will return sunny weather. Now, one thing to note here is I will mark this method as @tool, which means it has a special meaning. And I will provide a description of this method so that the large language model can know when this method has to get invoked. So I'm writing get weather forecast for specific lat and long values. There is one more step required. I will have to register this service with the tool. Let's see how to do that. Go to your Spring Boot application and create a bean for tool callback provider. So I will create a bean with the name as weather tools, and this will return tool callback provider, and this will take weather service, the service class which we just created as an argument. And inside the builder of this method, I will have to provide tool objects as weather service. This is needed so that the client, when invoking the MCP server, it would be able to discover that I have these many tools for my usage. So here we have declared the bean and we are good to go for the MCP server. Let's quickly revisit the changes that we have done. We made these changes in the application properties, turned off the logging, named our server, gave it a version name. Then we made a tool for us inside the service class. And finally, we registered our tool. We need to clean and install the application so that we can generate a manifest for MCP server. So we'll first do a clean and then install. And finally, we will get hold of the manifest which will be present in the target directory. Here, we just have to copy the path to this manifest, springai MCP server STDIO. We will copy the path and the MCP client will use this path to start the MCP server. Let's create a new project for Spring MCP Client in standard IO mode. We'll choose Maven, Java 21, again Java 17 also works. For dependencies, this time we will also add web because we want to expose a REST endpoint via which we can make a call and send the request. And we will add MCP client. Also, I am adding Olama over here because I am using locally running large language model. You are free to add any other large language model provider. Let's create the project. And now let's check their dependencies. Java 21, springai version 1.0.0, and we have added Spring Boot Starter Web, springai Starter MCP Client, and Olama. The whole purpose of adding Olama is because I am using a locally running large language model. In case you want to go with any other model provider that you have, OpenAI or any other, it is well supported by springai. Springai has support for a lot of large language model providers, and this is the beauty of springai. You can just switch the large language models by using different configurations without making any changes to the code. In place of here, you can also give OpenAI dependency for an example. Now let's see the configurations for this. Begin the configuration, I will have to mention my settings for Olama. In case you are using any other provider for large language model, you have to provide the required key value pairs. Example, if you are using OpenAI, then for OpenAI, you will have to provide the corresponding URL and the key for the OpenAI LLM provider. Okay, now my Ollama configs are ready. I will have to provide some configurations which are specific to Spring MCP Client. Let's see what those are. Let me set the tool callback to true and client type as sync. And now I have to provide a way so that this client knows the information of the MCP server that we had just created. Because the MCP server has the knowledge of the weather API. So the way to do this in standard IO transport mode is we have to provide servers configuration and we will have to create a new file. And that file is going to be MCP servers.json. You can name this file whatever you want. I'm naming this MCP servers config.json. And here while building MCP client, I am enabling the logging now. Spring framework.ai debug log I am enabling. Now we have to create this file MCP servers config.json. Let me create this file inside resources. I have copied the contents of this file that I need. I will have to declare my MCP servers. I'm naming it as springai MCP weather. You can name it whatever we want. And you'll have to pass some arguments for the Java command so that it can execute the manifest for Spring MCP server. Do note that the path of the manifest should be the same that you copied from the target directory of MCP server. After doing the configuration change, we have to create a controller so that we can expose the endpoint. I'll make this class chat controller and mark it as REST controller. Then I have to create a chat client. The responsibility of chat client is to invoke large language model. If you want to know how to create chat client or more about it, you can refer to the existing videos of this channel. We have covered how to create chat clients and how to connect them with Ollama. Apart from creating a chat client, we are also adding a dependency of tool callback provider. Now if you remember, this tool callback provider is the same bean that we had created when we had made the Spring MCP server. And when we made that bean, we had added that tool weather service inside our MCP server. We are injecting that same bean. This is the default system prompt that we are giving. We are asking the large language model to prioritize the contextual information. This is an optional thing if you want to do it. This is the main statement on line 15. We are adding the tools. What tool are we going to add? This will be the weather service. Building the chat client, all we have to do is to expose an endpoint. Here we are creating a get mapping with chat that we are going to use. And we will use a request param query. This query is something which the client has to pass, who is going to invoke the chat endpoint. We take the query which is sent by the user, create a prompt template, and we send the prompt to the large language model. Now a prompt is ready. All we have to do is get the response from the large language model. Now over this piece of code, you will see that we are nowhere making a direct invocation of the tool. We are just sending the prompt to the large language model. It becomes the responsibility of the large language model to decide if it has to make a tool invocation or not, based on the prompt which it just received. Now let's start the server. We are starting the MCP Client web application. It is started now. Now let's go on and test it out. Now let's start testing for this. I'm creating a prompt. My current location is lat 10 and longitude 10. Can I play tennis in this weather? Now remember, when we created the MCP server, we said that for lat 10 and long 10, we will say that the weather is rainy. Now I am not directly asking what is the weather. I am asking something which should take the answer of the question. So if you carefully see the logs, it says it is executing a tool call. After understanding the query, it found that it can make an invocation of the tool to get some additional context. So it made a call to the tool gave the answer that the weather is rainy. Using this information, it found out that obviously you cannot play tennis in rainy weather. Hence, this is the response it is telling us. The forecast indicates it will rain, and which could make outdoor activities like tennis challenging or even impossible. So this is where the additional context comes in. We did not tell the large language model fetches the weather or what is the weather. It found out that it can pass two parameters, lat and long, and get the value out of it. Thanks for watching this video. You can also explore other videos from this channel.